Okay, so if we have a triangle, any triangle, and we keep in mind that the angles and the sides across from each other have the same letters, that would mean that if this is capital letter A for this angle, then this side over here would be lowercase a. Capital letter B for this angle, this side over here would be lowercase b. And capital letter C for this angle, this side over here would be lowercase c. Then here's our formulas. Now these formulas are a little weird because they are squared, which means if you actually want to find the answer, you have to square root because you have to get rid of the square. So like if I want to find side A, my formula actually says a squared. Okay? A squared equals b squared plus c squared minus 2bc cosine angle A. Now see how that formula is kind of complicated, right? Like a complicated recipe. However, if you just stick to it and follow the steps and put the right stuff in the right places and use your tool calculator correctly, you should be fine. Okay, we're also going to do some examples. Now that's if you want to find side A. Is the same formula going to work for side B and side C? More or less, yes. You just have to adapt to the correct letters. So let's just write them down. Okay, so if I'm going to solve for B instead?
B squared.
Okay, so since A was what I was solving for here and B is in the formula, what's it going to be this time?
A.
There you go. Now what side is it we're trying to find?
B.
Side B. So that involves angle B. So every problem involves two sides and an angle. And the angle is across from the side that's out here. Okay, so help me figure out what C would be.
C squared equals B squared.
Okay, we could do B. Generally we stay alphabetical, we don't have to. A squared, how about A squared plus B squared? Is that okay? Minus 2
AB cosine C.
Good job. Okay, so 3 different formulas to find the 3 sides of the triangle, whatever one we want to find. Okay, we can use law of cosines anytime we know side, angle, side. So we have a side, an angle, and a side. We can use law of cosines. Or we can use law of cosines actually anytime we have side, 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 and that helps us to find the angle. Because we could plug in a side here, side here, side here, that same side here and here, and solve for the angle instead. We're going to do that on the other side of our paper in just a minute. Okay, so let's start by drawing a triangle for this first example here. Angle C is 127. That's a big, obtuse angle. If I have you talking, you're probably not listening, so if you could please hold your talking off if you need to communicate about something for later, and listen right now. Okay, so since angle C is a big, obtuse angle, I'm going to make my triangle with a nice obtuse angle for angle C, and I'm going to call that 127. And so then I'm just going to label my other corners. It doesn't matter which one is which, A and B. So across from angle A is what side? Side A. And across from angle B is what side? Side B, which just happens to be 12. So this is B and this is A. Alright. This says solve the triangle. Do you guys remember what I told you last time that solving the triangle means? Solving the triangle means finding everything that's missing. We're just going to simplify this and not worry so much about that today. So instead of solving the entire triangle, I'm just going to have you find one thing. And that one thing I'm going to have you find today is just side C. We're not going to worry about finishing the problem. We're just going to worry about finding side C. Okay? So this asks a question that I just answered for you. Which piece of the triangle should we solve for first? What did I tell you we were going to solve for first? C. But why is it that that's what we're solving for first? Any ideas why that's the one? Well, we have side A, we have side B, we have angle C. So based on the information we have, if we use this lower formula, do we have the right things to plug in to get C? Yeah, we do. Does that make sense? Okay, I also skipped this. Can we use law of sines to solve this triangle? Now let's pay attention to what it says. Law of sines, that's what we learned last time. Law of sines is angle, side, angle, 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 side, or side, side, angle. Remember how I accidentally, maybe it was a different class. Yeah, it was a different class, I did that in. Side, angle, side was not one of the options for law of sines. And that's what this is, a side, angle, side. The reason you cannot use law of sines is you don't know anything across from each other. We have big C, but we don't have little c. We have little a, but we don't have big A. We have little b, but we don't have big B. You can't use law of sines unless you have pieces across from each other, opposite. And we have nothing opposite. So we cannot use law of sines. So if you want to make a note about that, nothing is across from each other. Nothing is across from each other, and that is the problem with using law of sines. Okay, so we already talked about this too. Which of the three formulas that we just learned should we use for this problem? We should use the one that starts with C because we're solving for C, correct? So C squared equals A squared plus B squared minus 2AB cosine C. Okay, the trickiest part of these problems is using the calculator. But that we're not quite ready for that yet. I'm just kind of like venting that that's going to be the hardest part, is using the calculator, especially if you're using just your iPod calculators because of the way they go backwards. You have to be used to how to type it in. Okay, so I'm probably going to have to write out exactly how to type that in, and it might help if you use one of my calculators instead, because then it's a little bit more straightforward to type things in. I'll show you both ways, but let's just plug things in for now. Okay, so we're trying to find C. Now this is C squared. Are we trying to find C squared or just plain old C? Just plain old C, right? So maybe our formula would be better if we actually put a square root in there, because if all we're doing is solving for C, that means we need to square root both sides, don't we? Yeah? So we're not just finding C squared, we're finding C, which means we have to square root all that stuff that's in there. A squared plus B squared minus 2AB cosine C. When we find that whole number, then that big number in there, then we're going to square root that to get the answer for C. Okay, so here we go. C will equal the square root of A squared. Well, what is A squared from our picture here? Or from the original information. What's A? What is A? Hello? What is A? A is 53, and we're going to square that number. Okay? Next, our formula, our recipe says to do B squared. So from our original problem, what is B? B is 12, so we're going to do 12 squared. Okay? Then we keep following the formula. The formula or recipe says we now take -2 times A, which is 53, we already used it once, times B, which is 12, we already used that once, and multiply that times the cosine of C. Well, what is C?
127.
C is 127. This is actually a little bit of a strange problem, because last time I talked about that if you have an angle bigger than 90, you just subtract it from 180 and use that in your calculator instead. That's actually not going to work this time, because if you try plugging in, if you were to actually put cosine 127 in your calculator, you should get a negative answer. Why don't we try that? So get out your calculator. Come on, calculator. It's not turning. Okay, I'm wrong.
If you forgot your iPod, you can use your phone. They have the same thing.
No, you're going to come use my calculators is what you're going to use. Okay, so here's my calculator. Clear out what's in there. I'm going to type in 127 cosine. What do you notice about that answer?
It's negative.
It's negative. Now, there's a whole reason for why that's negative, that if you go on with pre-calculus in a few years, a couple years, then you'll understand why that's negative. But for now, you just have to trust me that, you know, if you try and do this problem on the chart, if your number's bigger than 90, I can teach you how to do it with the chart, but you're going to have to, basically, what you do is you take the number, you subtract it from 180, so let's do that. So 180 minus the number, what was it, 127? So that number is 53, and then you look up that number on the chart. So if I just use the calculator to do it, I get 0.6018. Does anyone recognize that number?
Positive.
That's the same number we just got, but this one's positive, and the 127, the bigger angle, gets a negative answer. And that's important. If you don't do it that way, you'll get a wrong answer if your angle's bigger than 90. Okay? I don't know if I've completely confused you now, but really the easiest thing to do is just put this all in the calculator. Now, I highly recommend that in order to prevent mistakes that might be made from a calculator, do each of these things kind of one at a time and write it down as you go. So I'm going to start by doing 53 squared. 53, and then there's a squared button. Is that really that big? Here, 53 squared. 2809? Is that what you guys got?
Yep.
Okay. Then 12 squared is 144, because 12 times 12 is 144. Then I'm going to go minus, and I'm going to multiply 2 times 53 times 12. So 2 times 53 times 12 is 1,272, but then I also have to multiply that times the cosine of 127. So I know I already did that once today, but let's just find it again. The cosine of 127 is negative 0.6018. If you use the chart, you would only be doing 4 decimals anyway, so I'm just going to write down 4 decimals. Okay? So now before you do anything else, you need to multiply these two things together. What happens when you multiply a negative or a subtract? What happens when you have a negative and then you multiply something that has a subtract in it? What's going to happen?
Positive.
Yeah, those two negatives will cancel and become positive, correct? So I have this negative 0.601815. I'm going to multiply that times 1272, and that gives me a negative 765.5, but that's like subtracting that negative number. So what does it actually end up doing because we have two negatives? Adding. So we're adding 765.5. Okay. Now take those three numbers and add them together. It's kind of like you're mixing the ingredients in a certain order, right? So let's just add them together. That's easy to do on your calculator. 2809 plus 144 plus 765.5. That gives us the square root of 3,718.5. Okay? Are we done? Is that our answer? No, we still have one more step. And what's the one more step? We have to square root that. Now remember back when we used factor tree to get a nice simplified answer? We're not going to do that this time. We don't care about decimals on this assignment, okay? Just go ahead and use the square root on your calculator and get an answer. Okay? So right now I have 3718.5 already in there. I'm just going to hit the square root button. So I get 60.9795. Those are all really big numbers. What's that going to cause this to do? It's going to round it up to 61. So all of these numbers will round this up just to an even 61. And there is the length of C. Is that cool? All right. There's another type of problem I want to show you how to do, but before I do that, I want everybody right now to do problem number 1 on your worksheet. Right now. I'm going to give you a timer.